All right, so let's look at an example. Your small business borrows money to pay for a large piece of equipment. If the interest rate is 4%, the amount borrowed is $50,000, and you pay monthly for 5 years, I want you to find what the monthly payment is and what the effective interest rate was. So go ahead, I'm going to pause the video here. I want you to open up the Excel workbook called Engineering Economics Examples from the Week 11 Canvas page for economics, and then we're going to work through this example together. All right, so I've got my Excel spreadsheet open, and hopefully you pause the video to open up your spreadsheet as well. So here we're looking at example 1, and again, it's always important to write what we're given. $50,000 is the amount borrowed. We have a 4% interest rate, and we're going to pay it monthly for 5 years. So we're asked to find the monthly payment amount. So let's go ahead and draw a cash flow diagram. Okay, so I'm going to draw a straight line here. $50,000 is what we borrowed. Okay, so we can treat that as money in our pocket. And then starting with month 1 all the way up to month 60, we are going to be making payments, monthly payments. Okay, and I'm not going to draw 60 arrows down, but you get the point. So we want to know what's the amount of money per month that we're paying off on this. Okay, that's our A value. Okay, so here I have the function that we would use in Excel. It's equal sign PMT. Then we have to have the rate, the end periods, the present value, future value is optional, and then the type is optional. So I'm going to show you what each of those is. So I'm going to put an equal sign. I'm going to type in PMT. The rate is 4%, so I'm just going to highlight B3. The N, and actually, sorry, I do have to divide. I have to divide that number by 12 because it is per month. In periods is, okay, so I do have to divide that value by 12 since it is monthly. The end period, so that's going to be our number 60. So 5 years times 12 months per year is 60. The present value is $50,000. And then I'm going to put in 2 periods because we don't need to put in the future value. We don't have one here. And then if I don't put anything for type, then when it will assume the end of the period. So the payment is timed at the end of the period. So that's fine. All right, so I end my parentheses and press enter, and then I end up with $920.83. Notice that it is in parentheses and it is in red, which means this is money coming out of my pocket. Okay, the second one that we're asked to find is the effective interest rate, and that function is given by equals effect, and then we have to put in the nominal rate and then the end periods per year. Okay, so I'm going to type in effect. The nominal rate is that 4% interest rate value, and then the end periods per year is we have 12 periods that we are calculating the interest. Okay, so I put those values and I end up with 0.0407, which is equal to about 4.07%. All right, the next example, and if you keep following the slides, you can find it further in the slides, but we're given that a bank charges the credit card holder 13.24% compounding monthly. A debt of $4,000 was accumulated and the minimum payment is $20. So how long would it take to pay off the debt completely if only the minimum payment is made monthly? How long would it take if a monthly payment of $50 is made? Okay, the number of periods for an investment based on constant payments and constant interest rate is given by this function. So we can use that to do our calculations, but I'm going to go ahead and again, I'm going to draw a cash flow diagram. Okay, so we have a debt, and I know I'm putting it on the positive, but that's because it was money basically that we were given. We were loaned. Excuse my handwriting. So we have $4,000. And then we want to know this value. Okay, and we're going to have monthly payments. So I'm just going to draw a bunch of arrows. Our monthly payment is equal to $20. Okay, and then in the second example, we basically have everything the same, except that we know our time period is going to change because now our A value is $50 per month. All right, so let's see how we can do that in Excel. So if I type out NPER, that's the number of periods. So my rate is going to be 13.24%. So I'm just going to put that in decimal form, 0.1324. The payment is $20, and that is a negative 20. It's coming out of my pocket. And then the debt of $4,000 is the present value. I can put that as a negative value. And actually, it doesn't matter if you put negatives or positives here. It's still going to return the same amount. I'm going to put double commas, and then, again, I'm going to ignore the type. We're going to assume it's at the end of the period. Oh, I did make a mistake. When looking at the interest rate, and I'm going to click up here on the formula bar, I made a mistake because my rate I didn't put in terms of months, so I do need to divide that value by 12. So it's actually 0.1324 divided by 12. All right, so now I have a period of 106 roughly months. So if I take that value and divide by 12, then I can get the amount of years. Okay, so that's the amount in years. I'm just going to highlight that so we can see. All right, now if I want to do it in terms of $50 per month, use the same function. My rate is 0.1324, and again, I need to divide that by 12. The payment is now going to be, I'm going to show you, it's the same whether you use positive or negative. I'm going to do a positive 50, present value, $4,000, and then I'm going to do double commas and in that, and I end up with 57 months. If I do the same thing, if I take that and divide it by 12, then I get 4.8 years. All right, so I'm going to go back to the PowerPoint presentation and just review what we did. This is where we started. So again, we use the payment function here for 4% interest, 5 years, and monthly payments on $50,000. For the effective interest rate, we used the function effect. And then we did financial functions looking at credit card debt. And this was the procedure that we followed in Excel. So the moral of the story here is try not to get into debt, but if you do, pay the debt off as quickly as possible. All right, so now you can take the quiz on troubleshooting in economics. And even though we're not meeting together in person, please remember to keep track of your bill of materials and the time you spend on your project, because you will get a total amount at the end of the semester, and that helps you determine the cost of your device. So thank you all for listening, and I hope you don't have any troubles with the quiz. If you need to contact me for whatever reason, again, I am Dr. Jennifer Lovely, and you can email me, jennifer.lovely@uky.edu. I hope everybody is doing okay.